In the last couple of videos, I showed you how to use the distance formula to find the length of a segment. Now we're going to learn how to use the Pythagorean theorem to do the same thing. Sometimes it's easier to use one method or the other, but either method will work in any problem. So first we need to review the parts of a right triangle. So we have two sides that are called legs and one side that is the hypotenuse. The hypotenuse will always be across from the right angle, and if that confuses you, just draw an arrow that starts at the right angle and you will be pointing at the hypotenuse. Okay, the legs are just the other two sides. They're not the same length necessarily. They just don't have special names. Sometimes I might call one a short leg and a long leg, but they are the legs. The hypotenuse gets a special name. Something to remember though, the hypotenuse is not always drawn at a slant. So notice in my picture that I gave you here, the hypotenuse is the bottom of the triangle, so it's going horizontal. So normally when you if I said draw a right triangle, most people would draw something that looks like this. And you might think the hypotenuse is the slanty side and the legs are horizontal and vertical. Well, that's not necessarily true. You can rotate a triangle so it's in any position. So here's another example where you might think, well, the hypotenuse is the slanty one. No, in both cases, if I drew an arrow that started at the right angle, it would be pointing at the hypotenuse, and that's what makes it the hypotenuse. So the Pythagorean theorem can only be used in a right triangle. Okay, so first of all, you need to check, do I have a right triangle? Then you can use the Pythagorean theorem. It looks something like this. I'm hoping this is familiar to you. You labeled the sides A, B, and C. Okay, so A and B are the legs. It doesn't matter which one you put on each leg. And C has to be the hypotenuse. So you always use the hypotenuse for C. The longest side has to be C.
You can always make a right triangle. So if we have R is at 2, 3, and S is at 4, -1, you may be saying to yourself, that is not a right triangle, but we are going to create a right triangle. And I like to kind of think about slope here. If you wanted to figure out the slope from R to S, you would take the rise and the run, and you end up with a right triangle. Okay, so the two pieces I just found are going to be the legs of the right triangle, and the distance that we're trying to find is the hypotenuse. So the distance we're trying to find will be the C, and it doesn't matter between the other two pieces which part's A and which one's B. Okay, so now since those are horizontal and vertical, all you have to do is count how many boxes there are for the side that's marked A. So it looks like it's 1, 2, 3, 4 boxes for A. So I know, oh boy, that I will have 4 squared. And then for B, if you count how many boxes you have, there are 2 boxes. So that's going to be 2 squared, and we're trying to find C squared. Okay, now this does not look nearly as complicated as the one before, but it's kind of interesting because we will end up with the same answer. So 4 squared is 16, 2 squared is 4, is C squared. Then you just add the pieces together, so you get 20 equals C squared. Now to solve for C, you take the square root of both sides, because a square root is the opposite or the inverse of a squared. So that means the square root and the squared are going to cancel out. So you end up with C is the square root of 20, which you will remember from up here. Oops, come on. Up here we had the square root of 20 and we did the factor tree. So we got the same exact answer. We just did it a different way. So I know that this has to be 2 root 5. So it will be the same. Okay, now the problem with doing Pythagorean theorem to find distance is you won't always be given a coordinate plane to use. Okay, it's pretty easy to use when you can actually see the right triangle, but sometimes you won't be given the coordinate plane. If you're not given the coordinate plane to look at, it's kind of easier to just throw these numbers into the formula. Okay, so just take these 4 numbers that they gave you, put them in for these 4 numbers. Okay, now if you're not given a coordinate plane, you can still do these problems. I'm going to talk about that real quick. Let's say you have 8, -2, and 3, 0. Just came up with those numbers. And you want to use Pythagorean theorem to solve for the distance between those 2 points, but you don't have a coordinate plane. What we did here for A and B, you'll notice, let's see here, A is the vertical distance between R and S. That's your rise. So it's basically what you get, what's the distance from 3 to -1. So if you think of a number line and you're at 3 and you want to get to -1, how many times would you have to jump over? Well, it would be 3 back to 0 and then another 1 past 0. So this would have a length of 4, and that's where this 4 came from. Okay, so let's try it here. If you just want to figure out the distance between, let's start with the x values. So the 3 and the 8, if you're on a number line and you want to go from 3 to 8, you would have to hop over, you'd hop once to 4, 5, 6, 7, 8. You'd have to make 5 hops. So the distance from 8 to 3 is 5. It doesn't matter positive or negative because we're going to square it, so the negative would disappear. But distances are usually positives, or are positive always. So you can just make it positive 5. Same here, if I go from -2 to 0, how far apart are those on a number line? To go from -2 to 0, you'd have to hop twice. So it has a distance of 2. Excuse me. So Pythagorean theorem here, you would be finding the hypotenuse as always, but your A and your B are 5 and 2. So you have 5 squared plus 2 squared equals c squared, which gives you 25 plus 4 is c squared. 25 plus 4 is 29. And then you would take the square root of both sides so that the squared and the square root cancel out. And then 29 is where you'd need to make a factor tree, but guess what? 29 is a prime number, so it cannot be reduced. So c equals the square root of 29 is the final answer. Okay, try some of these on your own.